Al-Dareyn Modern School hoyga aqoonta.
Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. Welcome to chemistry class, my dear students. This is Form 2 chemistry. Today we are going to learn about hydrocarbons as fuels. These hydrocarbons will act as fuels. As you know, according to the previous class knowledge, hydrocarbons, these are the compounds which are having only hydrogen and carbon atoms. When they burn and they act as fuel. The burning of hydrocarbon in the presence of oxygen is combustion. You know this already. If you see here, the main constituents of fuels. What are the main constituents of fuel? Coal, we use it as a fuel. Petroleum products or petrol, diesel, etc. And natural gas. These all are hydrocarbons. When hydrocarbons, they burn in the presence of oxygen. When they are burnt in air or in the presence of oxygen, they react. They react vigorously and release heat and light. And that process is called as combustion. This combustion process is highly exothermic reaction. Exo, releasing out, therm, energy, exothermic, releasing energy out. So they are highly exothermic reaction. The combustion is highly exothermic reaction. So it produces, here you can see, a lot of heat. On combustion, hydrocarbons produces lot of heat, energy you can say, and light also. The basic combustion reaction here, if you see, if you take methane, CH4, which is a methane, which is a carbon compound, reacts with oxygen, 2 moles of oxygen. This is 2 moles of oxygen. Nothing means 1 mole of methane reacts with 2 moles of oxygen. Here O2, here O2. This is CH4 and gives what? Carbon dioxide. Carbon in the middle, oxygen and oxygen. CO2 plus water plus heat and light. This is combustion. So here you see, our needs are fulfilled, energy needs are fulfilled with this combustion process in the homes, transportation, as well as in industries. So on the whole, we consider hydrocarbons as fuels which on burning in the presence of air releases carbon dioxide, water, combustion, heat, light. Light and heat. Next, hydrocarbons as feedstock. Some of the hydrocarbons, they are also used as feed for the animals also. So here in hydrocarbon industry, not only the hydrocarbons are used as fuels in automobiles, they are also used as raw materials in many industries. Raw materials in some industries like petrochemical industries. So here 2 meanings. One is feedstock, means basic stock or the source for the petrochemical industry or the source for the production of other chemical compounds. Here petrochemical industry. In this petrochemical industry, the organic compounds, hydrocarbons are also called as organic compounds. In petrochemical industry, the organic compounds are prepared from hydrocarbons. What are the hydrocarbons here? Petroleum and natural gas. These are called as petrochemicals. Some of the important petrochemicals, here you see, methyl alcohol, organic compound, ethyl alcohol, organic compound, formic acid, organic compound, chloroform, organic compound, carbon tetrachloride, organic compound, ethylene, organic compound, butadiene, organic compound, benzene, toluene, etc. These all are organic compounds, but petrochemical organic compounds. Next, in plastic industry, how these hydrocarbons are used in plastic industry as raw materials. So if you see here, plastic. In the plastic industry, to prepare polymers, synthetic man-made, to prepare synthetic man-made polymers, synthetic polymers or man-made polymers, we use hydrocarbon as a source material. So those synthetic polymers are called as plastics. Ba, in Somali the cover which we call as ba, it's a polythene cover. Ethene, many ethenes join and becomes polythene, it's a polythene cover. Next, polyester clothes, PVC, polyvinyl chloride, the pipes, the drainage pipe, the water pipeline pipes, the tanks, the water tanks, those all are from the plastic industry, which are these materials are made from the hydrocarbons. So these chemicals, these hydrocarbons, these raw materials, they are given shape and soft. When they are soft, they are given shape. After that, when they become cool, they become hard. So we can give shape only when they are cool or when they are soft. So this hardening make a durable article. When they become hard, it's durable, so its life will be more. For example, cups, plastic cups, glass, jug, plates, spoons, furniture items, etc. All these, they are in shape, right? How they are made? When they are soft, they are given shape. How they are made soft? On heating they are made into soft. When they are soft, they are shaped, and after that they are cooled, they become hard. So some of the automobile parts, electric and ravages items, and many other materials in our daily life which are made from the plastic, which are the outcomes of the plastic industry. Next, if you see here, rubber industry. Some of the hydrocarbons which are also used in rubber industry or preparation of synthetic, artificial rubber, not the natural rubber, it's artificial rubber. So acetylene is used to prepare butadiene rubber, which is used, footwear, slippers, footwear, tires, toys. These all are artificial rubbers which are butadiene rubber made from acetylene. So a good quality rubber, neoprene, is prepared from chloroprene, which is a hydrocarbon. So this is from the rubber industry. Next, if you move to the synthetic fiber industry, fiber which are artificial. So here also we see hydrocarbons plays a major role. Hydrocarbons are used to make synthetic fibers. Generally fibers we get from the plant products. So those are natural, and here the artificial fibers, nylon, rayon, polyesters. So these fibers are better qualities, they have good strength and they have good elasticity, give more resistance for wear and tear, more life. So clothes are made from these synthetic fibers. These clothes, they give more life, long lasting than that of natural fibers. Next, synthetic detergents. Naturally, artificial detergents which are used for the cleaning purpose. The long chain hydrocarbons. From beginning of the chapter, we already discussed what are long chain. Hydrocarbons which join, the units of hydrocarbons join to form long chains. These long chain hydrocarbons are obtained from petroleum products which are used to make synthetic detergents and washing powders. So washing powders and detergents are also made from the hydrocarbon. So we call them as synthetic detergents, products of petroleum. These detergents, so the composition, these are the sodium salts of alkyl hydrogen. These are the salts which are having sodium as one of the constituent of alkyl hydrogen sulfate. It's a compound. So these detergents, the detergents which are having these compounds, These detergents have better and strong cleaning properties than soap. Means they are good detergent. They clean very well. So synthetic detergents are good cleaners. So they can be used even hard water, where the water which can't use, which is not properly useful, in that hard water also for cleaning purpose we can use these detergents. Next, now let's see the general common points from this chapter. You know, hydrocarbons. Hydrocarbons are the compounds which are having hydrogen and carbon. The hydrocarbons are organic compounds which are having two elements as the constituents, carbon and hydrogen. As you know, alkanes, alkenes, alkynes, three types of hydrocarbons. Alkanes contain single bond, alkenes contain double bond, alkyne compounds contain triple bond. So as the hydrocarbons are classified into open chain and closed chain. The chain which is having no branch, not closed, having long branch, means at the ends they are open, so any number of units can be attached, so those are open chain hydrocarbons. And whereas the closed chain hydrocarbons, where they form circles, the end, the beginning of the beginning and the end point, they are completely closed. So those are closed chain hydrocarbons, and they are classified into saturated and unsaturated. As you know, saturated compounds contain single bonds, whereas unsaturated compounds contain double or triple bonds. So here, carbon compound having saturated hydrocarbons. The hydrocarbons or the carbon compounds which are having single bond are called saturated hydrocarbons. Here, these saturated hydrocarbons satisfy the tetravalency. Tetravalency means carbon shows tetravalency here with 4 single bonds. So now they are called as alkenes, and the alkenes have the general formula CnH2n plus 2n starts from 1, 2, 3, 4. The next, as you know, unsaturated hydrocarbons contain double and triple bonds. The compound consisting of double bonds are called as alkenes. Alkenes have the general formula CnH2n, while compounds consisting of triple bonds, they are called as alkynes. The alkynes have general formula CnH2n minus 2. Here in this concept, either in the future classes or for the examination point of view, whatever it may be, you have to remember these formulas. These formulas are most important to find out the number or the carbon compound number. Next, if you see alkenes, the suffix "ane" represents it is having single bond with respect to the number of carbon atoms ending. And next, alkanes. How alkanes are prepared? We can prepare alkanes by hydrogenation of alkenes or alkynes. To the alkenes shows double bond, alkynes shows triple bond. When we add hydrogen to the alkenes, the double bond breaks and forms single bonds. When we add hydrogen to the alkynes, the triple bond breaks and forms single bonds. So forming single bonds means it's forming alkane. So by adding hydrogen, that process is hydrogenation. The hydrogenation of alkenes or alkynes gives alkanes. So another, by reduction of alkyl halides, alkyl one hydrogen less, halide in place of that hydrogen, one of the halogen atom is fixed. So those compounds are alkyl halides. If we reduction of alkyl halide means removing the halogen, adding the hydrogen. So we can say addition of hydrogen is reduction. So reduction of alkyl halides also forms alkanes. The important reactions of alkanes: combustion and halogenation. Combustion, as we studied, burning of organic compound or carbon compound. Here we consider alkane in the presence of oxygen. The process is combustion. Halogenation, addition of halogen is halogenation. Now, combustion, burning of alkanes produces lot of energy in the alkanes, so alkanes are used as fuels. Next, alkenes are prepared. How they are prepared? Dehydration of alcohols. From the alcohols, from the organic alcohols, removing of hydrogen cause alkenes, and dehydrohalogenation of alkyl halides. So hydrogen and halogen, both removing of hydrogen and halogen of alkyl halide also gives alkenes. Already we discussed this in the previous topic, right? Alkenes, this is like revision. Alkenes give important reactions like halogenation and oxidation. Halogenation, alkenes invite the halogen to come and join. So, or we can say addition of halogenation. Addition of halogen is, what are halogens? 17th group elements are halogens: fluorine, chlorine, bromine, iodine. And oxidation also forms alkenes. Here oxidation means don't consider it as a loss of electron. So here the process is different. It means forming alkenes means breaking the single bonds, making it to double bonds. Oxidation of alkene produces important compound. Oxidation of alkene produces important compound. So what are those important compound? Glycol. We discussed glycol. Next, alkynes are prepared by the dehydrohalogenation of vicinal dihalides and dehalogenation of tetrahalides. D means removing. Dehydro, removing hydrogen. Dehalo, removing halogen. Dehydrohalogen, removing hydrogen and halogen. Tetrahalides, having 4 halogen atoms surrounded. So important reaction of acetylene is oxidation that produces oxalic acid. Remember, acetylene on oxidation, addition of oxygen produces oxalic acid. So my dear students, by this we completed this chapter. So my dear students, by this we completed this chapter. So in the next class we move to the next chapter.